All right. So part one, no big deal. Part two, doesn't feel like we need any help going over it or reviewing why or how, then we'll just go straight to the quiz. Anybody?
I'm fine, but if Stephanie, do you need to go over part two?
Well, I'm kind of having a hard time because I watched the videos and went through the book and stuff, but the actual SPSS, like entering the data and interpreting that, but I think as we do problems, then that'll become a little bit easier to me. Just not completely comfortable with using SPSS all the way yet, especially with this new data, this new way.
Well, it was hard because the text showed us how to do it in Excel.
Mm-hmm.
Yeah.
I had a problem with that too.
Yeah, there's a video on the one of the videos at the bottom of the preparation tab or whatever, or the individual preparation. It shows you how to do it in SPSS, and it's not hard. There's only one thing that you have to do different. If it's a single-tailed test, then you have to divide the probability in half. But other than that, it's pretty straightforward. It's a lot of the same stuff. You just plug it in and read.
Okay.
So, all right, then let's just do the quiz then.
Sure. Okay. I'm good.
Okay. Group 11, right? Or lesson 11 group meeting?
Yeah.
Yes.
You getting sick?
No, I'm just exhausted and allergies are bugging. So, you know, yay. All right, so number 3, it says, in previous lessons we've assumed the population standard deviation sigma was known. In this lesson we are making a different assumption about sigma. What has changed? We don't know it.
Correct. Okay. Number 4, the null hypothesis is mean equals 8, and the standard hypothesis is the mean is greater than 8, and the population standard deviation is not known. Becca collects a sample size n equals 9 and computes x bar equals 11 and s equals 6. Use this information for questions 4 to 5. Is O known? No.
So for number 5, what is the value of t? We would plug that into the t equals equation.
So it would be 11 minus 8. 6.
And I got 1.5.
I'm still punching it in. It helps if you do this correctly. Hold on.
I got 1.5 also.
Yeah, 1.5.
Do you need help, Stephanie?
What'd you guys get?
1.5.
What the heck did I do? Are you guys using the formula t equals x bar minus the mean, like 8, right? Divided by s divided by the square root of n?
Yes.
What did I do wrong?
Did you
So
get?
11 minus 8 divided by 6 divided by the square root of 9?
Yep.
So it would be 3 over 6 divided by the square root of 9.
Let's see, 3 divided by 6.
No. Well, you gotta make
So-
sure you put parentheses in. I did it the first time and ended up with 7 because I didn't put the
That's
parentheses in.
what I got, 7. What did I do? Oh,
So
I
you're
did.
going to do 3 over 2. You got to figure out your bottom part first.
It ends up
If you put it in the calculator right, you can do it all at the same time. 1.5.
Yeah. next
You
to
have to do like your parentheses, one more set of parentheses in your equation. You can type all in the same time, but obviously.
Oh.
the top and then divided by.
You guys got 1.5, right?
Yes.
Okay. All right, my turn. Use the following values which were pulled from the data file body 10. Copy and paste them into the software you are assigned to use. Use the null hypothesis of the mean equals 98.6 and alternative hypothesis is less than 98.6 and the level of significance is 0.05. Okay, so we want to know the X bar. Is that the mean of all means?
Mm-hmm. The sample mean.
Okay.
You guys are going to think I'm dumb here, but how, I don't have SPSS open and I'm drawing a blank. How do I open it? Because I don't want to get out of the group meeting.
You have to open it in a separate. Go to. Are you in the remote desktop?
Yeah.
You shouldn't. It shouldn't end your group meeting. Just you're gonna go look in under Start, in the bottom left-hand corner. Click on All Programs, and then look for the IBM SPSS software.
I'm not.
You click on statistics 23.
Yes.
But I had another test out of neurobiology. It's that same thing. Basically, I have the same one.
Where are you today, Brianna? Brianna?
I'm in the Benson.
Where?
In the Benson again. Most of my classes are in the Benson.
Okay, did you guys get it open?
I did, yeah. I'm just trying to copy and paste the data.
How about you, Carolyn and Brianna? Do you guys get it open?
Yeah. I have my answer.
Yeah, I did. I ran the Explore.
Did you get 98.22?
Yes, I got 98.22 for 6, and then for the S, I got a .922.
Yeah, okay.
Brianna, is that what you got?
Yes, it is.
The T-score, do we do that through the software, or do we do that individually? Because through the software, I got... Well, I'm actually just jumping ahead, sorry. You guys ready to go there?
Okay. Last time I tried to do it through the software, I didn't get the same answer, so I'm doing it by hand.
Okay, well, yeah, I got a huge number, so I'm going to do it by hand and see where we're at.
On number 6, what did you guys get? 98.220?
Yeah.
Looks up on my phone.
You can't do it by hand. Oh, yes, you can.
On number 7, can you guys remind me how to do that?
Number 7.
Yeah.
That is actually on the same, when you did the SPSS, it's on there. If you go to, you're looking at your description.
What is S? That's not standard deviation. What is it?
Sample standard deviation.
So is it 0.922?
Yes.
Yeah.
Okay, I was making it too hard.
You're not alone.
I think I overthink statistics just because it seems so intimidating. And then when I'm like, Stephanie, it's not that hard, then I'm like, oh, okay. Okay. Or it just seems really intimidating if you think about, like all the formulas and stuff. And
it is. It looks like it's harder than a lot of it boils down to something super simple.
Yeah.
Understanding the process.
So I just, I did the first part on SPSS, but I did the next part on the Excel thing, and I've got a different answer for the t-score and the p-value. I'm not sure if it's right, but...
What did you get for a t-score? I got a negative 1.843.
Yeah, that's what I got.
Oh, I got 1.845. Okay, I better do mine again.
But on the t-score, when you solve for t, you need to have the square root of n, but we don't have the sample size.
It's 20.
It's 20. That's what it gives you that in the if you just count out how many.
Duh. Okay.
But if you create a histogram, it gives you all that good stuff too.
Yeah.
And
Really?
If I went back to my SPSS, it's right there. I just didn't know.
Yeah. If you create a histogram, it'll give you the mean, the standard deviation, and the sample size right there at the side.
Okay.
Oh, and Brianna, did you get when you first did the t-test? Did you get like a 476 or something for t?
On my SPSS I did.
Okay. That's because I just did the same thing, and I'm like, wait a second, I just remembered. When you do it and you hit analyze, descriptive statistics, compare means. Sorry, compare means, one sample test, one sample t-test. That test value at the bottom, if it's 0, it's not going to do the same thing. It's not
Oh.
you're going to put in the test value, which is the 98.6.
Oh my gosh. Okay, that totally answered my question. Thank you.
You're welcome. I'm like, wait a second, I know there was a trick to this. And when I did that, it came up as a negative 1.843.
Okay, that was my problem on the homework too. I'm like, what is going on?
Like, that is not a normal number.
Yeah. So thank you.
You're welcome. And then for the probability, since it's asking for just less than, or it's saying less than, right?
Yeah.
So then it just needs to be a single tail test. So that means that the probability is 0.081, and that's for a two-tail test. So you divide that by 2, and you get 0.009. Right?
Where are you guys at?
The one sample test statistics on the SPSS. Oh, that's not 0.009. That was square rooting. It's 0.041.
How do you calculate the p-value?
Well, this one and the p-value, you have to. I think that one is one you have to get from the test or from the software.
Oh, so you got that. Okay, so that's the sig.two-tailed thing.
Yeah, the sig.two-tailed. That is the probability. So with the probability, because it's two-tailed, we need to divide that in half because you only want one side of the spectrum, not both sides. So when you divide that by 2, you get 0.0405, so it's 0.041.
Okay, thank you.
You're welcome.
What did you guys, on the t-score, did you get negative 1.843?
Yes.
Yeah.
And then did we do number 7 already, 0.922?
Yeah.
Yep.
It's not very.
Okay, and then the p-value, how did you guys solve that? I'm not understanding what you guys are saying.
In SPSS, you're
Yes?
gonna you need to do analyze. Like, did you do the analyze? Compare.
No, I
Okay.
didn't.
You go to analyze, compare, then one sample t-test. Then put the variable in your test. Make out your test variables, and then it says test value, and you're gonna put in 98.6.
Oh.
And then hit enter. Then your one sample test will come up, and your t is a negative 1.843. The degree of freedom is 19. That sig two-tailed, that's your probability right there, and that's 0.081 is for a two-tailed test. But for ours, our alternative hypothesis is one-tailed, so we have to divide that in half.
And how did you know?
Oh, whoops, sorry.
Our alternative hypothesis is that the mean is less than 98.6. So we're only looking at one side. We're not looking at both sides.
Because we're not trying to see if it's more than 99 or less than 98.
We're saying it's less than. Different would mean, I don't care if it's higher or lower, but it's different.
I don't remember learning that part. Where did you learn that, divided by 2? I mean, obviously it's one tail, two tail, but
It was in the tutorial for using the SPSS. For the stuff.
I watched the other ones, but I did not watch that part.
Me either.
I had to, because I was like, all right, what?
I'm glad that you watched it. Thank you. I don't know how you have enough time to do everything, Patty. I'm doing a million and one things, but your life seems even crazier, and I don't know how you're doing it.
I did it this morning while with my headphones on while yelling at the kids. Okay, you're dressed. Okay, go have some breakfast. Did you finish your breakfast? Now go rinse out your dishes. Now go brush your teeth. Are your shoes on yet? I kept hitting 5. Okay, where are you? Okay, do this.
Everybody in the car. I'll be right there.
Oh no, we're only about 6 blocks from the school. They ride their bikes, baby.
Oh, they do. Nice. I have to spend 25 minutes driving my kids.
Oh yeah. I used to drive a lot. Now I don't. When I had them at 3 different schools, we didn't have a parking pass for the high school yet, and we're out of boundary, so she doesn't get to take the bus. Then my middle schooler could take the bus, but the school is about it's almost 3/4 of a mile south of us. The bus stop is just over half a mile north of us.
Oh.
Like, what is wrong with school? And I'm like, and then it just didn't work out. So I was dropping off my high schooler at 7:30, and dropping off my middle schooler at 7:45, and then dropping off my little ones at 7:55. So I would just giant loop every morning, and then do the same loop picking up at 2:30 because both the middle school and high school get out at 2:30. So I'd pick up my high schooler, then run over and get my middle schooler. They'd walk to the gas station and I'd pick them up there with their friends, and then we'd drop them off, and I'd come back and get the little ones.
Oh,
Now,
my goodness.
well, you guys are big enough to walk, and my oldest can drive, and she's got a parking pass this year. So.
Life's a little easier this year.
Oh yes. I wouldn't get her a parking pass till she got her driver's license, and she didn't get her driver's license till halfway through her junior year, and I'm like, sorry, you're SOL on the top.
Don't have to tell you, babe.
I'm like, dang it, now I have to drive her. Anyway, all right. So let's see. Let's do number 10. What is the correct decision based on this evidence?
Oh, wait. For number 9, did you get 0.041?
Yes.
Okay.
So since
You put the 0 before the decimal. I think
it's 0.041.
Okay. So on the p-value, it says, let's see, you reject the null hypothesis if the p-value is less than the level of significance. If not, then don't reject. So p-value is less than the level of significance. P-value.
the p-value is less than the level of significance.
So you reject the null hypothesis.
No, you reject the. Wait, what?
You reject the null hypothesis, right?
Yeah.
That's
think so.
what my answer is.
Why do I always screw this part up? I cannot seem to get this one in my head.
I just remember that little ditty.
Because the p-value is 0.041 and the level of significance is 0.05, so it's less than that. And if it's less than the level of significance, then you reject the null hypothesis.
Yep.
I have to have it. I have to have it written down. I have it written down on a card that I can keep going back and looking at.
Well, I keep looking at it, but I keep going. But if it's less than, why are you rejecting it? Because it's, because it means
Backwards in your mind, right? That's what's just
Yes.
for me altogether. Everything's backwards.
It seems backwards in our mind.
I know it's not backwards, but in my head I'm like, but that doesn't work for me. All right, moving on. Well, more data to play with. Woohoo! All right, I'm hitting slap happy phase.
You need a power nap, Patty.
Dude, I need more than a power nap.
Full on 6-hour nap. You need a night's sleep. That's what you need.
Yeah. All you kids, cramp your style. Big time. Okay. So the test value is 40, right? Did I read that right?
Yes.
Oh, dang it.
I accidentally got out of SPSS. I'm having to reopen it and do it.
All right. Well, we're here when you make it back. All right. So for the p-value, did you guys get? Hold on. Which one is it? All right, so did you guys get for the p-value, did you get 0.995?
That's what I got. Yes.
0.905.
I got 0.995.
That's what I got. 0.995.
What did you get, Brianna?
Got 0.905.
Huh. Did you did you put in your test statistic as 40?
I think so.
Don't do that!
Sorry. Oh, I think I know what it is.
Did you figure out what happened?
I think when I copied and pasted, it didn't copy and paste all the numbers.
Oh.
Oh.
Yeah, if you don't scroll down low enough, you'll miss some. I had one, and I missed the 61, then when I did it again, I missed the 1, so it just put in 6.
Okay, got it now.
Okay. So did you get 0.995?
Yep.
Okay. How about you, Stephanie?
I don't know.
It's not back up yet?
It is back up, but I got lost.
So you're going to copy and paste open your SPSS and copy and paste your numbers.
I did that, yeah.
And then put analyze,
Okay, I did that.
compare means,
I did that.
and then you're going to have to put that 40 in the, I forget what it says. Let's see.
Where do
You hit the one sample t-test,
Sample t-test.
and the test value, you have to put 40.
Oh, right there. I was doing the one right ahead of it, right before. And then what is the confidence interval that you want?
It doesn't ask us that yet.
So just continue, cancel.
Although 0.01 level of significance is at confidence level 0.99 or 99%.
Come on, computer. Okay. Where do you guys find your p-value?
If you, it's the one that says sig two-tailed. That's your probability. That's your p-value right there.
Yeah, 0.995. That's what.
Yeah. Since this is saying it's different than, or it's just saying that it's not 40, it's different than, so it is that value. It's 0.995. And because that is greater than the level of significance, you fail to reject.
Nicholas.
Right?
Yeah, because it's more than 0.05. That's
Okay,
what I would say. But.
Okay. Decided to try another hypothesis. Now all we do is divide that in half. None of the values changed except for the one side.
That's fine.
Right?
Well, we're not going to divide it in half because this time.
Yeah,
Are you
but
talking about for the p-value?
for number 13, we just divide it in half for the p-value because everything else, all the rest of the details.
Oh, sorry. I didn't know we had moved on.
Oh, sorry. Sorry. Yep. No.
So we're on 13 right now, right?
Yeah, we're on 13.
Okay, so let me see. You decided to try another hypothesis. This time you use less than 40 and you keep the same level. So did the p-value increase or decrease? It decreased because you divide by 2, right?
Mm-hmm. Oh, well, yeah, I guess we didn't have to do the math. Divide anything, it's going to be.
Yeah.
Okay, so now that it's less than, no, wait. So, 0.05. Well, it's still more than 0.05, so you still fail to reject, right?
Yes. Compare the width of the confidence interval for questions 11 to the confidence interval for 13. Which one is wider?
Would it be 11?
Yes.
Yeah, because it's a higher confidence level,
It's bigger, yeah.
right?
Oh, goodness. Sorry.
Brianna, yeah?
Yep, sounds good. Took me a second.
I know, I'm like, you're not saying anything. Type it and tell us what you think.
But, yeah, that makes sense.
We've got fail to reject on both. The confidence, or the probability for number 13 decreased, if you understand. And then, so we failed to reject both, and so that, yeah, so number 11, the confidence interval is higher than the confidence interval for number 13.
Got it.
So question 11, on 15, question 11.
Yeah.
Yeah. Okay. Are we going to submit? Do you want to do it yet?
Yeah.
Yeah.
Sounds
Yeah.
good.
Is this like record time that we just did our meeting?
I think so.
Well, it's because we did work. We didn't gab for more than a couple minutes in there.
Oh, I missed one. You guys missed one?
It's
Yeah.
the last one.
Dang. They're the same.
Is that because we didn't change the percent that we were sure?
Oh, can we just divide it? Well, I wish we could click on it. Like some of my classes, you could click on it if you were wrong, and it would explain what you got wrong. Or
Yeah, that'd be
explain
nice.
why the answer is what it is, and I just wish that they did that here.
Well, the confidence interval is going to be the same. Duh. The confidence interval is the same because you're dealing with all the same data. The hypothesis is different, so your probability changes. Your probability and confidence interval are not the same thing.
Oh, okay, that makes sense.
So we're still dealing with all the same data. It's still.
So it would only change if your percentage changed.
Well, our level of significance didn't change, so our confidence interval didn't change.
That makes sense.
So, but our confidence interval would change if our percentage changed.
Because if I remember this right, your confidence interval and your level of significance correspond to each other. My notes, if I remember right, that was within level of confidence. If your level of confidence is 90, your level of significance is 0.10. If your level of confidence is 95, your level of significance is 0.05. If your level of confidence is 99, your level of significance is 0.01. So there's
if you're the percentage having to do with percentage.
Yeah, the percentage they add up to 1. So they would.
So it would only change if your percentage changed.
Yeah, because our level of significance didn't change. So.
Yeah. Okay.
Okay. Well, at least understand why we got it wrong.
What?
Hold on, I'm